So theorem 10.14 says find the distance between a point and a line in R cubed. Okay. Well, the distance between a point Q and the line in space is given by the length of the cross product PQ with vector U divided by the length of vector U, where U is a direction vector for the line and P is any point on the line. So how do we find such a distance? Well, the proof, by the way, is in the book. I'm not going to regurgitate it here, but you can read it. It should be pretty easy to read. Find the distance between this point, 4, 1, negative 2, and the line given parametrically, x equals 2t plus 2, y equals 2t, z equals t minus 3. So how do we do that? Well, a point on this line is 2, 0, negative 3. It's easy to find. Just let t be 0 in your parametrics, right? So that one's certainly on the line. You could find any other point if you wanted to. So anyway, PQ, remember what Q is. It's this one, right? And so we have this point, and to find a vector connecting them, we'd say it's 2i plus 1j minus 1, oh no, negative 2 minus negative 3 is like negative 2 plus 3, so 2i plus j plus k. And our vector u, the direction vector for the line, 2, 2, and 1. So there that is. So what do we need to do? Find the cross product and divide by the length of u. Well, the length of u, by the way, is the square root of 2 squared plus 2 squared plus 1 squared, which is the square root of 9, which is 3. And so the length of the cross product is ijk across the top, 2, 2, 1. Here's the 2, or sorry, 2, 1, 1, and 2. Where's the 2? Oh, here's the u is 2, 2, 1, and our direction vectors for the plane 2, 1, 1. So here we've got it. I won't take you through all this, but it's I times 2 minus 1, so that shouldn't be negative I. Not the way this is set up. 2 minus 1. Shouldn't be negative I, but you know, it's not going to matter anyway, because we're going to take the absolute value of it anyway. We're going to find the length of it, but really that cannot be right, because it's I times its minor, which is 2 minus 1. So 2 minus 1 happens to be 1, so it should be 1i here. Minus j times 2 minus 2, so there is no j, and that part works out right correctly. And k would be 2 minus 4, so negative 2. So for some reason or other, the signs in my software have this backwards. This really should be I, and then minus 2k, but it doesn't matter because the length of it's still square root of 5. Alright, so we got square root of 5 divided by 3. So the distance from the point to the line is square root of 5 over 3.